Of the many aspects there are to gun making, rifling barrels tends to present the biggest challenge to the home gun builder. Fortunately for us here in the US, there's no shortage of gun barrels, but if you can make your own from scratch, well, that's the holy grail. Hey guys, Mark Serbu, gun designer, gun nut. Today I'm going to show you how to take a piece of steel and turn it into a really nice gun barrel. It doesn't take CNC equipment, doesn't take a lot of time, doesn't take a lot of money. You can do this at home. As usual, the first step is cutting the material. I took 5 seconds and used my bandsaw, but you could easily use a hacksaw. It just takes a lot more time.
So hopefully you've got a bench vise, but if you don't have a bench vise, you can just do this holding it in your holding one hand and filing with the other hand, though that would really suck. But obviously the best choice is a milling machine or a lathe, and you just face it off. But if you don't have those things, $30 bench vise and a $3 file will do just fine. The bottom line is that if you take your time, you're patient, and you hold the thing nice and flat and steady, you can actually do a really nice job with just a file. Alright, now we're just going to break the edge. Okay, now we have to figure out where the center of this rod is. This is a 5/8 diameter rod, and we're just going to try to get a punch right in the center. These calipers are completely screwed up, but whatever. We want to punch a hole as close to the center as we can. So either use this stuff called Dicam or Dicam, whatever, or if you got a Sharpie, you can use a Sharpie. And you don't need to do this all over the whole thing, just as long as it's in the center, because that's where we're going to be scribing some marks. So now this thing is 5/8 diameter, like I said. Half of 5/8 is 5/16, which is 3/125. So we get it somewhere in that range. And see, it's really screwed up. So then you just go around from the edge to the center, make a bunch of sweeps here. And because we didn't get it exactly right, they're not gonna go through the center. If you really wanted to do it right, you could get it in the center, but we see where a center is appearing. Let me show you that a little better. Lo and behold, a crappy center has appeared. Yep, it's there. I can see it. Okay, now you're going to put a punch right in the center of where all those marks were. And you're going to beat the punch. Beat, pound, whatever. Alright, that's not a bad hit. Give it a little more. Yeah, that'll do. Okay, so this is a collet fixture. These are called 5C collets, and this is a nice way to be able to hold this straight, square, and all that stuff. You just stick it in the vise. I'm putting it off to the side because it's got some ground surfaces that are going to contact this. It's not perfect, but it's it's not bad. You see, it'll stand straight. So there are a lot of ways you can get around this. Now this collet block is about, I don't know, $40 to $50 for a set. They're not bad, and of course you got to buy a collet in there anywhere from $10 to $60. But you could just take a block of steel, drill a 5/8 hole in it, Loctite this in place, silver solder it in place, put a set screw inside, whatever, just to get this thing held and straight and square and all that stuff. Lots of ways to do it. This is a pretty good way. I'm just going to get lined up here in the little divot that we made with the punch. Yeah, that looks pretty good. Now a lot of people are constantly squirting coolant or oil or something when they're drilling a hole, and you can certainly do that, but this thing's not exactly breaking any speed records here. We're not putting out a lot of heat, so this is perfectly fine just to do it dry. Yeah. Does not look very straight. Oh well, that's what you get, right? That's why you buy good tools. Alright, so pretty crappy job. I think nationwide, if you're in a shop class and you do something like this, it's legal for the shop teacher to beat the crap out of you. And here's a good way to tell how much we screwed up. You can see on one side here we're 185 thousandths, on the other side we're 270, so 240, whatever. It's pretty bad, but the good news is on the other side we're only off by I don't know, 10 or 20 thousandths off from the actual center. So the good news about all of that is if this is going into something that is a much smaller diameter, which this is, this end gets turned down to 1/2 inch and this flange gets turned down to like 550 thousandths. So if you turn it between centers, or if you don't have tools like that, if you spin it between a couple of nails and you grind along it like Royal Nontouch would do, then you end up with something where you're still going to have the outside concentric to the inside. So the OD will be concentric to the bore. So even though it's crappy and it looks awful, we can make use of it. So we've got a lemon here, we'll make lemonade. Okay, I'm about to do something that you should never do. And that is ream a hole with a hand drill. That's it, ream a hole with a hand drill. Now this is a reamer, and a reamer is just a way to make a really nice, super accurate hole. And the thing about it, it only takes off just a little bit. So the hole I just drilled here is approximately 209 thousandths. Let's take a look at that. That's the drill anyway. Drills tend to, maybe it's a 213. I think it was supposed to be 209. Anyway, looks like we got about a 212 thousandths hole. This reamer is going to 217 thousandths, and that's about right. You just want to take about a few thousandths off. So this I will put some oil on, because I'm not a complete maniac. And yeah, you probably shouldn't hold it with your hands either. And I'll probably end up switching to putting it in the vise, but let's at least get it started here. Yep, don't ever do this. All right, let me put it in the vise now. Okay, what you should never do, part 2. Do not ream with a hand drill. Yeah, this is not cool. Woohoo! Made it! Alright, here's an instant replay of it coming through the hole.
The dog, man! You got a fucking dog in your neck! You're crazy, you're crazy, man.
I'm gonna go ahead and just
I like you.
unchuck it and pull it through that way. I'm not gonna tempt fate.
Alright, now you can't see, but we've actually got a pretty decent hole in there. Next is the exciting part, the rifling. Okay, now this is a rifling button. This is made out of tungsten carbide, at least this part is tungsten carbide. And this other part is just plain old steel, and this is the pilot. This is what gets shoved in the barrel first. And what's interesting is this is tungsten carbide, very hard, same kind of stuff they make cutting tools out of, end mills and all that. And it actually has the same sort of coating that they put on end mills nowadays, ALTIN or something like that. It's some kind of a plasma deposited super hard coating and very wear resistant. But what's neat is this is, you can see the two bumps here. The bumps are actually oversized, so when this goes through the hole that's, you know, this diameter, it it crunches the diameter out and becomes the groove diameter, and then the actual grooves on here are what correspond to the bore diameter in your barrel. So the actual grooves in your rifling, it's just the material left behind that these grooves actually go around. It's pretty interesting stuff. And this is pushed through very fast. I mean, 10, 20 inches a minute, no problem. And of course, it's going to be a hell of a lot slower when I use a vise to crunch it through, but whatever. There you go, rifling button. All right, now this isn't exactly in the manual. There's no manual. I'm using some moly grease here, and I'm just shoving it in the hole there. Nothing very scientific about it. All right. So it looks like there's grease most of the way down there. Now, the smart way to do this, which I'm not going to do today, is you put it in your, like I said, a hydraulic press or a hydraulic cylinder setup just to do this, or you put it in your CNC and have the CNC plunge through with a rod. And it's pretty cool. You got these rods, they're available really cheap. This thing's like $4. This is actually kind of too small, but it'll do for the end. But this is a hardened tool steel, ground, nitrided. Just chuck that up in your CNC and you push it through. But now we're just going to use the vise. All right, so here we go. Start crunching it through there. And this is not too hard to turn the vise handle right now. The only thing that worries me, these teeth are kind of aggressive, and maybe it won't let this button twist when it wants to twist, because it does twist on its own. Okay, so got it going part way. Now I've got to go and put other stuff in there to push that sucker in. And you just use what you got lying around. Here on 50 cal valves table, I found a shoulder screw, and it looks like a perfect candidate. Yeah, this is not the right way to do this, folks. But look at that. It works. It's only going to go so far because this is a 1/4 inch shoulder screw, and as we remember here, we have a 217 thousandths hole. It's on its way. All right. This is the standard mechanics trick. Beat on it. Just kidding. That's not just mechanics. That's everybody. Everybody's ever worked on anything mechanical, anyway. Always comes down to a hammer and beating on it. So, found a punch that, yeah, that'll work. Now the thing you want to do is you want to make sure your punch isn't super sharp on the edges, because you're going to go through it, or just be really careful you don't hit the edges as you're going through, because you're going to ruin your brand new spiffy rifling. So let's see here. Let's see if this works at all. That's a really bad idea. Beating on carbide with hardened steel, because everybody knows carbide is pretty brittle. So, yeah, I could feel it moving, but God, I would not recommend doing this at all. This is really dumb. Yeah, don't do that. Let's just try using the punch and on. Now, your best choice, if you're going to do some cheesy crap like this, your best choice is to get yourself some drill rod. And like just smaller than the diameter that you made the hole to. Like the hole's 217, so what is it, number 7 drill rod is like 201 or something like that. Look at that. Okay, so we're gonna look really carefully and make sure we're actually pushing and not just bending. Nope, it's bending. Yeah, it takes several pounds. It takes several thousand pounds of force to push the rifling button through there, and yeah, you kind of really need to make the old bottle jacket. Now, actually, our issue here is not with the force. We got plenty of force available here. This is not stout enough. So you know what? I'm gonna go find some drill rod and have another crack at it. All right, I got another one of these rods I was talking about earlier. These plastic molding industry ejection pins. So this thing here, this one I think was $7, and again, it's hardened tool steel. It's so it's super strong ground. It's got a polished finish. It's amazing, and it's nitride on top of that. So this is just all kinds of awesome for $7, which I just can't beat that. So what I'm going to do is, you know, I'm going to bring the barrel over here. This barrel is about 3 1/4 inches long, and I'm going to make it so this is long enough to get this all the way through. I'm thinking this is stout enough that it won't buckle like those punches, because those punches get pretty thin. So we're just going to go a little bit over here. Yeah, I got a messed up hose situation over here. Really fun fact about this tool here, this crappy pneumatic cutoff wheel, I actually bought this thing in 1994 when I was making guns in my garage. And this is to, you know, avoid having to cut stuff, you know, cut material with a hacksaw. I had my little pneumatic cutoff wheel. And so this thing's 23 years old. We still freaking use it. It's beat to hell, and it doesn't work that well, but you know what? It works. Hey, it's getting used right now. So go ahead and cut this sucker off. Really should be using a vise, but you know, I'm going Royal Untouch on this today. Alright, now I'm going to take this to the buffing wheel. You can't file this because the file will just glance right off it because it's so hard. It's so hard a cat can't scratch it. Alright, so do you have a grinding wheel? If you don't have a grinding wheel, you should get one. You can't really live without one in the shop. So let's give it a shot again. That does not want to play nice. Man, that's it's still buckling. You know what? We need a short piece too. Damn. All right, what do you think? The holy grail of thingies that push rifling buttons through barrels? I don't know. We will find out. Yeah, if you want to look that up, Euler column buckling causes a lot of problems. Because this little piece of steel here, if it was just really short and fat, it would take literally tens of thousands of pounds to cause it to fail. But in this mode, if it's a slender column, it takes almost nothing, literally hundreds of pounds of force. Okay, so I'm pushing it and it's going in now. Thank God. All right, so it's in a good inch. Now we'll switch over and see if it's in far enough where this thing is not sticking out too far. I kind of worry about it, but all we can do is try it, right? Doesn't help that we've got these freaking giant aggressive teeth on the vise. If we just had a pocket in the vise, if we had a machine pocket on this side and a machine pocket on this side, then it would support it much better and it would be much less likely to buckle. Alright, so it seems like it's going in. I believe. Yes. Woohoo! That's awesome. And just for proof, I'll put a little Sharpie mark on there. There, see that? It's going in. Oh, I felt it stop. And sure enough, the rifling button's trying to come out. Okay, so what do we do now? We can be cheesy and try to just put that above the vise and have it just push it on out. Which may or may not work. It might work. Haha. And we're getting lucky now. Yeah, this is a really cheesy way to do this. And there are a few hidden dangers here. We are dealing with materials that are hard and could shatter. So instead of just reading glasses, I should be wearing safety glasses. And I just really shouldn't be doing this at all, but just wanted to show you that you can rifle a barrel with just really basic, crappy tools. And there we are. Rifling button is out. Barrel is rifled. Woo! Alright, so if you want to do this right, you're going to shoot the material in the collet fixture as you see here. And I've already buffed it a little bit to try to get it as round as possible. Now we're just going to face across it with a giant face mill. And there you go, it's all faced off. Now I'm just going to touch off and find the exact center. And I'm going to center drill, and ream it.
Okay, somehow I don't have the footage of the reaming step, but you know what that probably looks like. Unlike the way we did it before, which you should never do, hand drill and a vise. But anyway, here you can see this goes much, much faster, and we end up with much better results. But what do you expect? You know, throwing really expensive machines at the problem. And here you see an ejector pin again, pushing the rifling button through, but this time using the CNC machine. And as you can see from the collet nut turning, the rifling button twists on its own as it pushes through the hole in the barrel. That's pretty interesting. Note that if you pull the button, you have to have a method for twisting it at the same rate of twist that the button is made for. And here's the result. The most obvious thing with a barrel made with cheap tools is that the lands are dark. And why is this? It's mainly due to reaming with a hand drill. Remember I said never to do that? Well, this is one good reason. It came out slightly oversized, and the sizing bump on the rifling button didn't get to do its job. Yeah, we still have a rifle barrel and it's not bad, and it'll probably shoot okay too, but it's definitely not within spec. Honestly, if we just reamed it in the drill press, it probably would have come out just fine.
Well, that's it. Now you can see a crappy way to make your own rifle barrel. It's actually pretty cool. It's one of the neater things I've done in my last, 30 years of making guns. There's just something strangely rewarding about rifling your own barrel. I don't know. But lots of good stuff learned there. To you younger guys who don't even take shop class anymore, hopefully you learn some tricks about working with your hands with metal. And yeah, I've been doing this stuff a long time. I still love it. Coming up in a future video, the rifling buttons, they're expensive and they're very specialized. I'm going to show you how to make your own rifling button with just a $2 piece of drill rod and a file and a torch. And that's going to be really exciting for you super cheapskates. And of course for the pros, you know what you need to do, and hopefully this wasn't too boring for you. Anyway, thanks. I really appreciate watching these videos. It takes me forever to make them because I got so much other stuff going on. And as you can see behind me, we're just a day away from Hurricane Irma hitting. That's why I hurried up and finished this thing up, because who knows if we're going to even have any power here in Tampa in a couple days. Again, thanks for watching. Appreciate you all. Have a good one. Okay, just doing a trial fit of the barrel and barrel extension here. And yep, it fits. Great, awesome.